Alright, imagine this, you're on a hiking trip. You start walking up a hill, and as you climb, your height increases, right? But then, you hit a downhill path, and now you're going lower. Now, here's the fun question. What if I told you we can predict when a function is climbing up or going down just by looking at its graph? Sounds cool, right? Well, that's exactly what we are going to explore today, increasing and decreasing functions, a concept that allows us to figure out where a function is growing and where it's shrinking. Think of it like this. When you're going uphill, you're increasing your height. The graph of a function that's increasing also rises as we move from left to right. But if you're descending, the graph falls, it's decreasing. So, all we need to do is figure out when a function is climbing and when it's dropping. Pretty fun, right? Now, let's break this down a little further. We can mathematically define increasing and decreasing functions. A function f from the set of real numbers to the set of real numbers is called increasing on an interval if for any 2 points x1 and x2 within that interval, where x1 is less than x2, we find that f of x1 is less than f of x2. In simpler words, as x increases, the function f of x increases too. On the other hand, a function is decreasing on an interval if for any 2 points x1 less than x2, we have f of x1 is greater than f of x2, meaning as x increases, f of x is actually going down. Now, let's talk about a constant function. If f of x equals c, where c is a constant, the graph is simply a horizontal line showing no change in the output no matter how x changes. Here's where the derivative comes into play. The derivative of a function tells us about its rate of change. If the derivative is positive everywhere in an interval, the function is increasing. If the derivative is negative, the function is decreasing. And if the derivative is zero, the function is constant. Simple, right? Let's see this in action. Consider the function f of x equals x squared. Its derivative is f prime of x equals 2 times x. For values of x greater than 0, f prime of x is greater than 0, meaning the function is increasing. For values of x less than 0, f prime of x is less than 0, so the function is decreasing. It's like the graph is going uphill when x is positive and downhill when x is negative. And that's all thanks to the derivative. Let's try a couple of quick examples to make this even clearer. For the function f of x equals 7 times x minus 3, the derivative is f prime of x equals 7. That's always positive, so this function is always increasing, no matter where you are on the graph. Now let's look at f of x equals x cubed minus 3 times x squared plus 4 times x. Its derivative f prime of x equals 3 times x squared minus 6 times x plus 4. By solving f prime of x equals 0, we get critical points and the function still behaves in an increasing manner. Now, here's the fun part. How do we find the intervals where the function is increasing or decreasing? It's a 4-step process that's easier than it sounds. Find the derivative of the function. Solve for critical points, where f prime of x equals 0. These points can tell us where the function switches direction. Test the sign of f prime of x in the intervals created by the critical points. Conclude whether the function is increasing or decreasing based on whether the derivative is positive or negative in those intervals. For example, take f of x equals x squared minus 4 times x plus 6. Its derivative is f prime of x equals 2 times x minus 4. Solving f prime of x equals 0 gives us x equals 2. This divides the real line into two intervals, negative infinity, 2 and 2, positive infinity. We can now test points in these intervals to see if the function is increasing or decreasing. Let's work through a more advanced example. Consider f of x equals 4 times x cubed minus 6 times x squared minus 72 times x plus 30. First, we calculate the derivative. F prime of x equals 12 times x squared minus 12 times x minus 72. By solving f prime of x equals 0, we get critical points at x equals negative 2 and x equals 3. Now, let's test the intervals. For the interval negative infinity, negative 2, f prime of x is greater than 0, so the function is increasing. For the interval negative 2, 3, f prime of x is less than 0, so the function is decreasing. For the interval 3, positive infinity, f prime of x is greater than 0, so the function is increasing again. Let's also look at a trigonometric example. F of x equals sine of 3 times x. The derivative is f prime of x equals 3 times cosine of 3 times x. By solving f prime of x equals 0, we find critical points at x equals pi over 6 and x equals pi over 2. From 0 to pi over 6, f prime of x is greater than 0, so the function is increasing. From pi over 6 to pi over 2, f prime of x is less than 0, so the function is decreasing. And that's a wrap on our exploration of increasing and decreasing functions. By now, you should be confident in determining when a function is rising or falling by simply looking at its derivative. Remember, the derivative tells us the rate of change of a function. It's your key to understanding how the function behaves. In the next video, we'll dive into Maxima and Minima, learning how to find the highest and lowest points of a function. Stay tuned for more mathematical fun.